Go a very good afternoon, everyone. So, we'll start today's live session. Just a second. I'll share my PPT. Okay. So, this is the last live session of our course, Introduction to Crystal Elasticity and Crystal Plasticity. So, I'm Ankur Khapre, the teaching assistant, and the course instructor of this course is Professor Swarup Bagh from IIT Guwahati, and I'm a PhD student in School of Chemistry, University of Hyderabad. So let's just move to our question number one. I'll show my PPT slides. Please wait for some time. We'll see. Somebody is joining. Yeah, no, fine. Okay, just a second. Okay, so we'll start with question number one. So question number one is, what is the correct sequence of length scale in multi-scale modeling approach? So this question is straightforward, as professor already mentioned in the class. Uh, so the four length scale in multi-scale materials modeling, there will be continuum, microstructure, atomistic, and electronic structure. So from you can continue from hierarchy level, you can follow the hierarchy level from continuum to electronic structure. So the correct sequence of length in multi-scale modeling approach will be option number first, because first it is coming from length wise, continuum is coming first, higher level, then microstructure second, then atomistic third, then electronic structure. There, chalo. Okay, so the right answer is first. This is not correct, and here atomistic is coming before microstructure. That is also wrong. The last one is also wrong. What is the question number two? Polycrystal plasticity predicts stress strain response in the following scale. So here, as you can see in this diagram, first is dislocation phenomena. Second is single crystal plasticity. Third is polycrystalline plasticity, and fourth is ALE 3D design product. Okay, so here they are asking polycrystal plasticity, polycrystalline plasticity. So it is following in which scale? It is following the meso scale. So the right answer will be the meso scale. In atomic scale, what is that? Dislocation phenomena. So this will be wrong. And micro scale also you can see here. The single crystal is coming in micro scale. So this micro scale thing is also not possible. And continuum scale, this is the largest one. So it is also not possible. It is bigger than the scale will be bigger than meso scale. So the question number third is the minimum length scale for discrete dislocation is of the order of. So here given in the these values are given without any unit. So just it is a mistake. Just consider it is in a meter. Okay. Now the question is asking about the minimum length scale for discrete dislocation is of the order of. So discrete location is already straightforward. The professor already have taught, that is around 10 to the power minus 8 meter. So the answer will be this one. 10 to the power 5 is in crystal plasticity. So it is not answer. This is for grain. And 10 to the power minus 3 is continuum plasticity. That is also not possible because of the macro scale. And 10 to the power minus 12, this is lower than the atomistic length scale. So this is also not possible in discrete dislocations. Okay. Okay. Now question number question number 4. So which of the following approach performs simulations at different length scales simultaneously? So which is performs this? Here, as you can see, the concurrent approach directly, it is also straightforward. Professor already taught this. The perform simulations at different length scale simultaneously. And there also, like question also they have asked simulation. And here also it is same. So concurrent approach will be the correct. Hierarchical approach, it is not for this one. Hierarchical is like some bigger to higher, it will go like this. Hierarchical approach, or we can say larger to smaller. So this is also not correct. And upscaling we know already. Upscaling in the sense like smaller to will go toward the bigger cell. So it is called upscaling. Hierarchical approach. Okay. And downscaling, also downscaling, opposite of the upscaling, from continuum to atomic strip. So the correct answer is concurrent approach. Now, the question number 5. The atomistic method can study the dynamic process on time scale up to the order of. As you can see in this picture, already professor had taught, we can also predict this. These electrons are coming here, nanometer level. I'll just divide into some parts. This part, atomic is like this part, atoms. This is mesoparticles, and this is elements. So you can see the nanometer part, electrons are coming in nanometer part. This is coming around below micron and above nanometer. Atoms are like this. Actually, this part is still here, atoms and this one. And micron mesoparticles will come microns and meter. So this is the length scale. Already have here it's mentioned. Here it is mentioned. What about the time? Time you can see here. Time is femtosecond to second. It is increasing like this. As you can see here in electrons, it is coming till here. So it is a nanosecond, below nanosecond. What about the atoms? It is coming below microsecond. So already they have asked about the atomistic methods and the time scale up to the order of. So you can see this is below microsecond. So you can tell up to 1 microsecond. Since it is a below, suppose it is a 1 microsecond. It is below atomistic time scale. Atomistic methods time scale. Okay, their methods will come. Now, after that, so this is coming around 1 micron. This is also wrong because 1 second it is coming about this mesoscale up to mesoscale. 10 second is not at all given here, so second it will go to macro scale, and 1 microsecond, millisecond also it will come here itself somewhere. So maybe we can say that this macro will be in second and meso will be in millisecond. So this is also wrong. That's how you have to solve this. What about question number 6? What is the approach used in upscaling? So upscaling, as we know by word itself, upscaling in this upscaling means lower to higher. So the first option is use results from a lower scale calculation to obtain parameters for higher scale methods. So this is the correct option. Why? We have to the lower scale the calculation results we have to use to obtain the parameter of higher scale methods parameter. Okay. So what exactly we are doing? That lower scale calculation result calculation we are using for higher scale parameters. That method is called upscaling. What about the option 2? Use high scale information to build parameters for lower scale methods. That is not possible. Okay, and inductive approach also not possible. None of the also not possible. So already the option number 1 is correct. Okay. Now question number 7. Which of the following length scale the maximum power of degree of freedom exists in general? So maximum they are asking here. So as we know, in continuum, that is a discrete, like it is a in length scale wise, it is the longest one, largest one. So it is not possible. What about the major scale? Major scale also the largest scale. Degree of freedom will be less. Macro scale compared to meso, macro will be having less. And atomic scale will be the highest one. Degree of freedom. Because the length scale, it is the lowest one to count. So that the atomic scale, according to the length, atomic scale, atomistic scale, the maximum number of degree of freedom exists in general. Okay. So now question number 8. Just a second. Question number 8, they are asking, question is like this. Which of the following behavior is true for macro scale approach? Which of the following behavior is true for macro scale approach? first one is, as you can see here itself, the answers are already given by professor's video, is given in the professor's video. So for macro scale, the homogeneous material, you can see here, homogeneous material points, and the another one is for this, okay, continuous plastic flow behavior. You can see here. So according to this, the correct answer is continuous plastic flow behavior, because they're asking macro scale approach. So macro scale approach, this is the macro scale approach. You got that? Materials exhibit homogeneity, not possible because it is in inhomogeneity. It is in macro scale. Macro scale, again, plastic flow occurs on discrete planes. This is also not possible because it is coming in micro scale. Sorry, micro scale. And the last one is also flow is anisotropic and orientation dependent. That is also coming in micro scale. So this is not possible for macro scale approach. So for macro scale approach, what is the possibility? Continuous plastic flow behavior. Okay. So the question number 9 is, the temperature is represented in atomistic scale. What is that? As you can see here, thermodynamic energy in atomistic scale, this thermodynamic energy, this won't be applicable. It will be applicable in molecular scale. Then atomic displacement, also not possible. And atomic forces, it is also not possible. Temperature won't represent these things. Only the random velocities it will represent. Now the question number 10, which of the following is not the multi-scale modeling approaches? So here you can see MAD method is also uses for the multi-scale approaches. QC also uses for QC method also uses for multi-scale modeling approaches, and CAD approach also. See, the crystal plasticity is not a method, multi-scale modeling method. It is a phenomenon. It is a phenomenon, not a method. So the answer is, they are asking not the multi-scale modeling approach. So the answer is this one, crystal plasticity. Okay. So here we'll wind up this session. If you have any questions, you can ask me. Thank you.